Okay, in question 4, we've got a population of butterflies, and so we have a dominant brown coloration and a recessive white coloration, so pretty standard Mendelian inheritance here. 40% are white. So what it's giving us is Q squared, which is 0.4. And then it says calculate the following. So it says percentage of butterflies that are heterozygous, so we want to know this. And the percentage of homozygous dominant individuals, so we want to know that as well. Okay, so let's go ahead and, again, let's unsquare that. So let's take the square root of 0.4. .63, which would make this 0.37, right? And then square 0.37. 0.37 times 0.37, 0.14. Okay, so that's this one, 14% are homozygous dominant. And then the next one, how do we get this? Again, we know that plus 2pq equals 1. So 0.4 plus 0.14 equals 0.54. That must mean that this is 0.46. So 46% must be heterozygous, because remember 2pq is the heterozygous condition. Cystic fibrosis is a recessive condition that affects very small number, 1 in 2,500 babies in the Caucasian population in the United States. Calculate the following. The frequency, so it's a recessive condition, so cystic fibrosis is recessive. So, so 1 in 2,500, what's that in percentage, right? 1 divided by 2,500. All right, so that's as a decimal, 0.0004. Or if it was percent, you go times 100. But so it'd be 0.04%. But remember, when you do these calculations, you use the decimal format. So Q squared is going to equal 0.0004. Okay, so what's the frequency of the recessive allele in the population? So we want to know, this is asking what's Q. And the frequency of the dominant allele, that's P. And the percentage of heterozygous individuals, that's 2pq. So we want to know those two things. And so, again, it doesn't hurt to just kind of work things out on the equation here. I like to do that. It seems to me to make sense. So again, we're looking for this and this and that. But we're given Q squared. It's 0.0004. So again, same pattern, unsquare that. Take the square root of it, 0.0004. It's 0.02, which make this 0.98. Okay, so I already got the frequency of the recessive allele, 0.02. Frequency of the dominant allele, 0.98. Okay, now let's keep working. Let's square that, 0.98 times 0.98, 0.96. So 0.9604 plus 0.0004 equals, subtract 1, 0.0392. And it's percentage, so times 100. 3.9% are carriers. 3.9% are carriers. If 2 of those carriers have offspring, there's a 1 in 4 chance that their offspring would have cystic fibrosis.